Hi guys, in this video I'm gonna talk about 7 differences between deep learning and machine learning. Three of the hottest fields today are artificial intelligence, cybersecurity, and cloud computing. In particular, artificial intelligence has made a huge leap in recent years. AI-based solutions such as language-to-language translation, face recognition, and suggestion systems have become a part of our lives. Machine learning and deep learning are two important areas of AI. Although these two fields are different from each other, they are sometimes used interchangeable. In this video, I will tell you the differences between these two fields. Let's go ahead and take a look at agenda for this video. In summary, let me explain what is AI, and then what is machine learning, next what is deep learning. Lastly, I am gonna talk about the differences between machine learning and deep learning. Before going ahead the video, we produce content related to AI and data science. Please don't forget to subscribe, press the bell icon and leave a comment. Let's get started. In the past, when we thought of AI, we immediately thought of robots. From medicine to education, from finance to biology, there is no area where AI is not used. In fact, in the 1950s, the idea of AI was, can machine think like humans? Came up with the question. AI, which has shown various developments since those years, has made a great leap, especially in the last 10 years with the increase in the data, the advancement of computer hardware, and the discovery of new algorithms. Now, humanoid tasks such as voice recognition, image detection, decision making, the translation between languages are done by intelligent computer programs. For example, computer facial recognition or driverless cars were a problem that could not be solved until recent years. With AI techniques, such problems can be solved in many areas. Machine learning is the science of extracting information from data and is a subfield of AI. In the past, a machine was explicitly given rules, and outputs of inputs were obtained according to these rules. For example, let's consider spam filtering. With classical methods, which words will be spam were given to program. Then this program was expected to find spam emails. However, there may be many different words in the emails that can be spam. It is very difficult to identify these words and given them to the program one by one. The technique of the program learning the rules, instead of explicitly entering the rules into the program, is called machine learning. With machine learning, hidden patterns in data are found. Machine learning is widely used in many fields, such as finance, education, biology, and medicine. For example, machine learning techniques are used to find abnormal account movements and prevent fraud. Machine learning is divided into three subfields. These are supervised learning, unsupervised learning, and reinforcement learning. Let's take a closer look at these subfields. For supervised learning, the data must have a label. In this technique, tags are used to train algorithms. Regression and classification problems can be solved with supervised learning algorithms. For example, you want to estimate house prices in a city. Imagine you have inputs such as the location of the house, its age, and the number of rooms in your dataset, as well as the output variable for the price of the house. You can use regression techniques such as linear regression and artificial neural networks to find the relationship between these inputs and the output variable. If the output variable is contain numerical values such as house prices, regression, and categorical values such as gender, classification algorithms are used. For example, it is a classification problem to predict whether the patient will have cancer by examining his weight, age, and diseases. Note that this dataset has categorical labels cancer or not cancer. Decision trees, logistic regression, or support vector machines can be used to solve the classification problem. If your dataset doesn't have labels for the data, you can use unsupervised learning algorithms for analysis. Using these algorithms, you can find hidden patterns or group data, unlabeled data without the need for any tests. Problems such as clustering, reducing the size of data, finding anomalies can be solved by unsupervised algorithms. The most commonly used algorithms for unsupervised learning are techniques such as key-means, principal component analysis. Reinforcement learning is based on the principle of maximizing reward and minimize penalties. The learning system, called the agent, observes the environment and takes action. As a result of this action, he receives a reward or penalty. The system chooses the best strategy using these rewards and penalties. For example, you can consider DeepMind's AlphaGo program for reinforcement learning. This program became world champion by beating world champion in the game of Go in 2017. AlphaGo has learned how to win the game by analyzing millions of games and playing against itself. Deep learning is a subfield of machine learning that emerges by imitating the human brain. Deep learning bases of artificial neural networks, which is a machine learning algorithm. Artificial neural networks have one hidden layer, while deep neural networks have multiple hidden layers. Classical machine learning algorithms could not analyze big data. In addition, machine learning techniques have had a hard time analyzing unstructured data such as images or videos. New deep learning algorithms have been developed to analyze both big data and unstructured data. One reason AI has developed in recent years is deep learning algorithms. Let's take a closer look at some deep learning algorithms. Convolutional neural networks are a type of artificial neural network consisting of multiple convolution layers. CNNs were developed with inspiration from visual region of the human brain. CNNs are often used in areas such as computer vision and object detection. You can use RNNs models to predict the future using time series. For example, with RNNs, you can predict stock prices in the stock market. You can trade using this model. In cross-language translations, models based on RNNs are used very often. Machine learning and deep learning are two important areas of AI. These two fields are often thought to be the same, but these two fields are not the same. The most important difference between machine learning and deep learning is the amount of data. While machine learning algorithms work with small or medium-sized data, large data is required for deep learning algorithms. While low or medium computers are sufficient to perform machine learning analysis, powerful computers are needed to perform deep learning analysis. While feature engineering is required for machine learning, feature engineering is not needed for deep learning. In other words, some features may be related to each other while performing machine learning analysis. This relationship can make your analysis biased. So it's important to set features for machine learning analytics, but not for deep learning. Since machine learning algorithms work with small or medium-sized data, the training time is short, 1 or 2 hours at most. But because deep learning algorithms use big data, the training time is long, such as days or weeks. While simpler problems can be solved with machine learning, complex problems such as face recognition and translation from language to language can be solved with deep learning. While machine learning techniques can only analyze structured data, deep learning algorithms can also analyze unstructured data such as images, audio, or video. Some machine learning algorithms, such as regression, are known to work, but deep learning algorithms are a black box, and how they work is unexplainable. In short, with the development of techniques and the internet, there have been great developments in the field of AI, especially in the last 10 years. Machine learning and deep learning are two important subfields of AI. Although these two fields have important differences, they are often confused with each other. In this video, I have explained several important differences between these two fields. I hope you enjoyed this video. Please don't forget to subscribe, press the bell icon, leave a comment, and give me a like. See you in the next video. Bye for now.